In the next few videos, we'll explore 3 techniques for automating repetitive tasks. These are while loops, for loops, and recursion. Each of these techniques are used to tell the computer to repeat a task, but each takes a slightly different approach. We're going to learn how to write the code for each and how to know when to use one technique instead of the others. So, are you ready? Let's get started. First off, we're going to talk about while loops. While loops instruct your computer to continuously execute your code based on the value of a condition. This works in a similar way to branching if statements. The difference here is that the body of the block can be executed multiple times instead of just once. Check out this program. Can you guess what it does? Before we execute it to find out, let's go through it together line by line. In the first line, we're assigning the value of 0 to the variable x. We call this action initializing, to give an initial value to a variable. In the line after that, we're starting the while loop. We're setting a condition for this loop that x needs to be smaller than 5. Right now, we know that x is 0, since we've just initialized it, so this condition is currently true. On the next 2 lines, we have a block that's indented to the right. Here, we can use what we learned about functions and conditionals to identify that this is the while loop's body. There are 2 lines in the body of the loop. In the first line, we print a message followed by the current value of x. In the second line, we increment the value of x. We do this by adding 1 to its current value and assigning it back to x. So, after the first execution of the body of the loop, x will be 1 instead of 0. Because this is a loop, the computer doesn't just continue executing with the next line in the script. Instead, it loops back around to reevaluate the condition for the while loop. And because 1 here is still smaller than 5, it executes the body of the loop again. It then prints the message and once more increments x by 1. So the x is now 2. The computer will keep doing this until the condition isn't true anymore. In this example, the condition will be false when x is no longer smaller than 5. Once the condition is false, the loop finishes and the next line is executed. And finally, the last line of our code prints the last value of x. So now that this code makes a bit more sense, what do you think will happen when we execute it? Ready to find out? Let's execute the code and see what happens. So we had 5 lines with the message, "not there yet," and then at the end of the script, the value of x was 5. This was a simple example of how a while loop behaves. As we've said before, we're learning the building blocks of programming. Once you know those building blocks, you can combine them to create more complex expressions. As an IT specialist, while loops can be super helpful. You can use them to keep asking for a username if the one provided isn't valid, or maybe try an operation until it succeeds. Knowing how to construct these expressions can help you get your computer to do a whole lot with only a little bit of code. It's pretty powerful stuff we're learning here. Now that you've got an idea of how a while loop works, let's spice it up with another example. In the last video, we saw a very simple example of a while loop. We looked at a basic syntax of the loop and how it works. Let's now apply this knowledge to a similar example, but this time with a while loop inside a function. Can you work out what this function does? In this example, we start out by initializing a variable called x. In this case, we initialize it with the value of 1. Then we enter our while loop, which checks to see if the value inside of the x variable is less than the parameter n that the function received. If that comparison evaluates to true, then the code inside the while block is executed. Say we pass a value of 5 as a parameter to this function. In the first pass through the loop, x is always equal to 1, so the comparison 1 smaller than or equal to 5 would be true, and we'd then enter the body of the loop. In the body, we first print a message indicating that the current attempt number, and then we increase the value of x by 1. To increment the number, we're using a slightly different expression than before. X plus equal 1 is a shorthand version of x equals x plus 1. You can use either expression since they both mean the same thing. The process continues until the result of the comparison isn't true anymore, which happens when x is bigger than n. In our current example, this would be when the value of x is 6. Let's see it in action. In these past examples, we've used the simple conditions of a number being smaller or equal than another number. These are common conditions, but they're by no means the only conditions you can have in a while loop. It's common, for example, to call a separate function that evaluates the condition, like this. In this case, there's a lot of code hidden behind functions, and it's doing stuff we don't see. There's a getUsername function that asks the user for a username, and a validUsername function that validates that username. And all this is happening in just a handful of characters. As you can see, you can pack a lot of punch into just a short line of code. In this case, the body of the while loop will be executed until the user enters a valid username. The important thing to remember is that the condition used by the while loop needs to evaluate to true or false. It doesn't matter if this is done by using comparison operators or calling additional functions. The conditions used in while loops can also become more complex if we use the logical operators that we encountered when looking into branching, and, or, and not. This lets us combine the values of several expressions to get the result we want. Okay, we've now covered what a while loop is and learned its syntax and basic behavior. Some of this stuff can be a bit tricky, and you're doing great. Keep sticking with it. As we've called out earlier, writing loops allows us to get our computer to do repetitive work for us. Since one of the main benefits of writing scripts in IT is to save time by automating repetitive tasks, loops are super useful. So, let's make sure you avoid some of the most common mistakes people make when writing loops. One of the most common errors is forgetting to initialize variables with the right value. We've all made this mistake when starting to code. Remember how in the earlier examples we initialized our variable x to 0 in one case and to 1 in the other? When we forget to initialize a variable, two different things can happen. The first possible outcome, and the easiest to catch, is that Python might raise an error telling us that we're using a variable we haven't defined, which looks like this. As we've done with other errors we've come across, we can look at the last line to understand what's going on. This error type is a name error, and the message that comes after it says we're using an undefined variable. It's straightforward to fix. We just need to initialize the variable before using it, like this. Fixed. Now, there's a second issue we might face if we forget to initialize variables with the right value. We might have already used the variable in our program. In this case, if we reuse a variable without setting the correct value from the start, it will still have the value from before. This can lead to some pretty unexpected behavior. Check out this script. Can you spot the problem? In the first block, we correctly initialize x to 1 and sum to 0, and then iterate until x equals 10, summing up all the values in between. So by the end of that block, sum equals the result of adding all the numbers from 1 to 10, and x is 10. In the second part of the code, the original intention was to get the product of all the numbers from 1 to 10. But if you look closely, you can see that we're initializing product, but forgetting to initialize x. So x is still 10. This means that when the while condition gets checked, x is already 10 at the start of the iteration. The while condition is false before it even starts, and the body never executes. Let's see how this problem would look. In this case, it might be harder to catch the problem because Python doesn't raise an error. The problem here is that our product variable has the wrong value. If you have a loop that's gone rogue and not behaving as expected, it's a good idea to check if all the variables are correctly initialized. In this example, we need to set x back to 1 before starting the second loop. As always, the best way to learn is to practice it yourself. Make sense? Remember, if you ever feel stuck or a little unsure about something, you can always ask for help in the discussion forums. These forums are there to let you get the help you need when you need it. so don't forget to use them. So, to recap, whenever you're writing a loop, check that you're initializing all the variables you want to use before you use them. And don't worry if you don't get it right the first time. We've all been there when learning how to code. As we've called out before, the way to master programming is to practice, practice, practice. Keep practicing until you're comfortable. And even then, it's still okay to make mistakes. So don't feel like you can't, loop back around to review and practice everything we've covered so far. You may remember by now that while loops use a condition to check when to exit. The body of the while loop needs to make sure that the condition being checked will change. If it doesn't change, the loop may never finish, and we get what's called an infinite loop, a loop that keeps executing and never stops. Check out this example. It uses the modulo operator that we saw a while back. This cycle will finish for positive and negative values of x. But what would happen if x was 0? The remainder of 0 divided by 2 is 0, so the condition would be true. And the result of dividing 0 by 2 would also be 0, so the value of x wouldn't change. This loop would go on forever, and so we'd get an infinite loop. If our code was called with x having the value of 0, the computer would just waste resources doing a division that would never lead to the loop stopping. The program would be stuck in an infinite loop, circling back around endlessly. And we don't want that. All that looping might make your computer dizzy. To avoid this, we need to think about what needs to happen for a loop to be successful. In this example, we said that x needs to be different than 0. So we could nest this while loop inside an if statement, just like this. With this approach, the while loop is executed only when x is not 0. Alternatively, we could add the condition directly to the loop using a logical operator, like in this example. This makes sure we only enter the body of the loop for values of x that are both different than 0 and even. Talking about infinite loop reminds me of one of the first times I used while loops myself. I wrote a script that emailed me as a way of verifying that the code worked. And while some condition was true, I forgot to exit the loop. Turns out those emails get sent faster than once per second. As you can imagine, I got about 500 emails before I realized what was going on. Infinitely grateful for that little lesson. When you're done laughing at my story, remember, when you're writing loops, it's a good idea to take a moment to consider the different values a variable can take. This helps you make sure your loop won't get stuck. If you see that your program is running forever without finishing, have a second look at your loops to check there's no infinite loop hiding somewhere in the code. While you need to watch out for infinite loops, they're not always a bad thing. Sometimes you actually want your program to execute continuously until some external condition is met. If you've used the ping utility on Linux or macOS system, or ping-t on a Windows system, you've seen an infinite loop in action. This tool will keep sending packets and printing the results to the terminal unless you send it the interrupt signal, usually pressing Ctrl-C. If you were looking at the program's source code, you'd see that it uses an infinite loop to do this, with a block of code with instructions to keep sending the packets forever. One thing to call out is it should always be possible to break the loop by sending a certain signal. In the ping example, that signal is the user pressing Ctrl-C. In other cases, it could be that the user pressed a button on a graphical application, or that another program sent a specific signal, or even that a time limit was reached. In your code, you could have an infinite loop that looks something like this. In Python, we use the break keyword, which you can see here, to signal that the current loop should stop running. We can use it not only to stop infinite loops, but also to stop a loop early if the code has already achieved what's needed. So, quick refresh. How do you avoid the most common pitfalls when writing while loops? First, remember to initialize your variables, and second, check that your loops won't run forever. Okay, how are you doing? If all this talk of loops is starting to make your head spin, remember that there's nothing wrong with looping back around and reviewing what you've learned. It's the quickest way to stop feeling like you're running in circles. All right, feeling good? Great, then we're ready for a different type of loop. In this video, we're going to meet the for loop. A for loop iterates over a sequence of values. A very simple example of a for loop is to iterate over a sequence of numbers, like this. Notice how this structure is kind of similar to the structures we've already seen. The first line indicates the distinguishing keyword. In this case, that's for, and it ends with a colon. The body of the loop is indented to the right, like we saw in the while loop, the if block, and the function definitions. What's different in this case is that we have the keyword in. Also, between the for keyword and in keyword, we have the name of a variable. This variable will take each of the values in the sequence that loop iterates through. So in this example, it'll iterate through a sequence of numbers generated using the range function. There are two important things I want to call out about this range function. First, in Python and a lot of other programming languages, a range of numbers will start with the value 0 by default. Second, the list of numbers generated will be one less than the given value. In the simple example here, x will take the values 0, 1, 2, 3, and 4. Let's check this out. So there we have a very basic for loop. It iterates over a sequence of numbers generated by the range function. When using a for loop, we point the variable defined between for and in this case x, at each element of the sequence. This means on the first iteration, x points at 1, on the second iteration it points at 2, and so on. Whatever code we put in the body of the loop will be executed on each of the values, one value at a time. As we said earlier, the loop's body can do a lot of things with the values it iterates. For example, you could have a function to calculate the square of a number, and then use a for loop to sum the squares of the numbers in a range. Iterating over numbers looks very similar to the while loop examples we showed before. So you may be wondering, why have two loops that look like they do the same thing? Well, the power of the for loop is that we can use it to iterate over a sequence of values of any type, not just a range of numbers. Think all the way back to our very first Python example in this course. Remember our trusty hi friends script? In it, we saw a for loop that iterated over a list of strings. It looked like this. We'll talk a lot more about lists later on, but for now, you only need to know that we can construct lists using square brackets and separate the elements in them with commas. In this example, we're iterating a list of strings, and for each of the strings in the list, we're printing a greeting. The sequence that the for loop iterates over could contain any type of element, not just strings. For example, we could iterate over a list of numbers to calculate the total sum and average. Here's one way of doing this. Here, we're defining a list of values. After that, we're initializing two variables, sum and length, that will update in the body of the for loop. In the for loop, we're iterating over each of the values in the list, adding the current value to the sum of values, and then also adding 1 to length, which calculates how many elements there are in the list. Once we've gone through the whole list, we print out the sum and the average. We'll keep using for loops in our examples every time we want to iterate over the elements of any sequence and operate with them. Some examples of sequences that we can iterate are the files in a directory, the lines in a file, the processes running on a machine, and there's a bunch of others. So as an IT specialist, you'll use for loops to automate tons of stuff. For example, you might use them to copy files to machines, process the contents of files, automatically install software, and a lot more. A few weeks ago, I had to update a lot of files with different values depending on their contents. So I used a for loop in a script to iterate over all the files. Then my script took different actions based on an if condition and updated all of those files for me. It would have taken me forever if I had done this manually file by file. If you're wondering when you should use for loops and when you should use while loops, there's a way to tell. Use for loops when there's a sequence of elements that you want to iterate. Use while loops when you want to repeat an action until a condition changes. And if whatever you're trying to do can be done with either for or while loops, just use whichever one's your favorite. I'm more of a while gal myself, but it's totally your call. Next up, we've put together more examples to help get you more practice with for loops and discover some of the cool things you could do with them. In the last video, we talked about the range function and how it generates a sequence of numbers starting with 0. Sometimes, though, we don't want to start with 0. For these situations, the range function also allows us to specify the first element of the list to generate. We do that by passing 2 parameters to the function instead of 1, like in the next example.
Product equals 1 for n in range 1 to 10. Product equals product n print product.
In this example, we're calculating the product of all numbers from 1 to 10. For this operation, it's important that we start with 1 and not with 0. If we'd started with 0, the whole product would be 0. Additionally, we can specify a third parameter to change the size of each step. This means that instead of going 1 by 1, we could have a larger difference between the elements. Let's check out this example of when you might want to do something like this. First, we're defining a function that converts a temperature value from Fahrenheit to Celsius. And we're simply using a conversion formula to do that. Then, we have a for loop that starts at 0 and goes up to 100 in steps of 10. Notice that we're using 101 for the upper limit instead of 100. We're doing this because the range never includes the last element, and we want to include 100 in our range. The body of the for loop prints the value in Fahrenheit and the value in Celsius, creating a conversion table. Let's see this in action. That example got you feeling the heat? Don't worry, there's a quick rundown of what we've learned. The range function can receive 1, 2, or 3 parameters. If it receives 1 parameter, it will create a sequence, 1 by 1, from 0 until 1 less than the parameter received. If it receives 2 parameters, it will create a sequence, 1 by 1, from the first parameter until 1 less than the second parameter. Finally, if it receives 3 parameters, it will create a sequence starting from the first number and moving towards the second number, but this time the jumps between the numbers will be the size of the third number. And again, it will stop before the second number. This might sound like a lot to remember, but don't panic. As we've said before, you don't have to try to memorize it all, just keep practicing, it'll soon become second nature. You're doing great getting your head around all these loops. I think you're ready for something a little bit more complex. We're going to explore what happens when you get loops inside of loops. Does that make your head spin? Don't worry, we're about to break it down for you with a couple of examples. Have you ever played dominoes before? There's a bunch of fun games you can play with these tiles. In case you're not familiar, each domino tile has 2 numbers represented by a collection of dots carved on each half of the tile. The numbers go from 0 to 6. Tiles can be rotated so that each combination of numbers is represented only once in a set of domino tiles. In other words, the 2-3 tile is the same as the 3-2 tile, and there's only 1 per set. Now, imagine we wanted to write a program that prints each domino tile in a set. If we take all of the tiles that have 0 on the left, we can print tiles with numbers from 0 to 6 on the right. That should be easy to do with a for loop. But what about tiles that have 1 on the left? Well, we need to skip the 1-0 tile because that one was already printed as 0-1. So, we could print a list of tiles with 1 on the left and numbers from 1 to 6 on the right. When we look at 2, we would need to skip both 0 and 1, and so on. Are you following along? How do you think we'd write the code for this? Turning this into code means that we'd need to write 2 for loops, one inside the other. This is what we call nested for loops. Check out how this looks in Python code.
For left in range 7, for right in range left 7, print, we're going to do left bracket plus str left plus pipe plus str right plus close bracket end equals space. And print.
In this code, we're using a new parameter that we pass to the print function. This parameter is called end. Normally, once print has taken the content we passed and written it to the screen, then it writes a special character that creates a new line called the new line character. If we want print to write something else instead of the new line character, we use the end parameter, like we see in this example. Notice how the second for loop iterates over a different number of elements each time it's called as the value of left changes. Depending on what you want to achieve with your nested loops, you may want both loops to always go through the same number of elements. Or you might want the second loop to connect to the first one. Let's look at a different example. Let's say you run a local girls' basketball league in your town. You have 4 teams that will play against each other in the league, both at home and away. You've stored the names of the teams in a list, like this. We want to write a script that will output all possible team pairings. For this, the order of the names matters because for each game, the first name will be the home team and the second name is the away team. And of course, what we don't want to do is have a team playing against itself. So, what statement do we need to use to avoid that? To do this, we need to use a conditional that makes sure we only print the pairing when the names are different. Check out what this looks like.
For home team in teams, for away team in teams, if home team not equal to away team, print home team versus away team.
Success! As you can see, nested loops are super useful for solving certain problems, like pairing teams. What it doesn't solve is the question, who would win in a face-off between dragons and unicorns? If only there were some code for that. Anyway, we've seen that nested loops are a handy tool, but we need to be careful not to just blindly apply them to any problem. Why? Well, because the longer the lists your code needs to iterate through, the longer it takes your computer to complete the task. Let's say your manager asks you to do an operation that will run through a list of 10,000 elements. If the operation takes 1 millisecond per element, the whole loop would take 1 millisecond times 10,000 to complete, which is 10 seconds. Now, imagine we add a nested loop that has to go over the same 10,000 elements. This means that each iteration of the outside loop would do a full iteration of the inside loop, which again would take 10 seconds to go through the whole list. So now the whole iteration takes 10,000 times 10 seconds, which is 100,000 seconds. That's over 27 hours. I have the patience of a gnat, so that would definitely not work for me. This doesn't mean we shouldn't use nested loops. They're a useful tool when solving problems that require them, but we need to be careful of where and how we use them. Throughout this course, and ones coming up, we'll look at a lot of techniques that can help us pick the right tool to use for each type of problem. Up next, we'll look into some common errors that you might come across when writing your for loops and what to do about them. We've now seen how to write for loops, combine them with functions, nest a for loop inside a different loop, and even combine a nested loop with conditionals. Nice job, you're chugging right along. But before we're done with for loops, let's check out some common mistakes you may come across while trying this yourself. As we've called out already, for loops iterate over sequences. The interpreter will refuse to iterate over a single element. As you see here,
For x in 25, print x.
in this example, we're trying to iterate over the number 25. Python prints a type error telling us that integers are not iterable. There are 2 solutions to this problem, depending on what we're trying to do. If we want to go from 0 to 25, then we use the range function.
So for x in range 25, print x.
But if we're trying to iterate over a list that has 25 as the only element, then it needs to be a list. And that means writing it between square brackets.
For x in list 25, print x.
You might be wondering why you'd ever want to iterate over a list of one element. And that's a good question. Well, this kind of issue usually happens when you have a function with a for loop inside it, which is iterating over the elements of a list received by parameter. Say, for example, you have a function that fixes the permissions of a list of files received by parameter, and you want to call this function to fix the permissions of just one specific file. To do that, you need to pass the file as the single element of a list. Let's check this out with some code we're familiar with, our friendliest of Python examples. Hi, friends. We're going to modify it to have the greetings inside a function. We've defined a greetFriends function that receives a list by parameter and iterates over that list, greeting each friend. But what if we only want to greet one friend instead of 4? Well, we still need to define a list, but with only one element. But first, let's see what would happen if we don't do that.
Greet friends. Berry.
Huh, not what we expected, right? Well, what's going on here? This happens because strings are iterable. The for loop will go over each letter of the string and do the operation we asked it to do, which in this case, print a greeting. Depending on what you're trying to do, you may actually want to iterate through the letters of a string, but in this case we don't. So, to sum it up, if you get an error that a certain type isn't iterable, you need to make sure the for loop is using a sequence of elements and not just one. And if you find your code iterating through each letter of a string when you want it to do it for the whole string, you probably want to have that string be a part of a list. We've now learned how to write while loops and for loops. You might remember, for loops are best when you want to iterate over a known sequence of elements, but when you want to operate while a certain condition is true, while loops are the best choice. Recursion is the repeated application of the same procedure to a smaller problem. Have you ever played with a Russian nesting doll? They're a great visual example of recursion. Each doll has a smaller doll inside it. When you open up the doll to find the smaller one inside, you keep going until you reach the smallest doll, which can't be opened. Recursion lets us tackle complex problems by reducing the problem to a simpler one. Take our Russian nesting dolls, all nested inside each other, and imagine we want to find out how many dolls there are in total. We would need to open each doll one by one until we got to the last one, and then count how many dolls we've opened. That's recursion in action. Here's another example with a more complex problem. Imagine you're in a line of people and you want to know how many people are in front of you. And let me tell you, I can't stand long lines. Anyway, if the line's long, it might be hard to count the people without leaving the line and losing your place. So instead, you could ask the person in front of you how many people are in front of them. Since this person will be in the same situation as you, they'll have to ask the same question to the person in front of them. And so on until the question reaches the first person in the line. This person can confidently reply that there are no people in front of them. So then, the second person in line can reply 1, the person behind them replies 2, and so on until the answer reaches you. Okay, I know the chances are pretty small that all those people would play along just so you can know where you are in line, but it's a useful way to visualize how recursion works. How does this translate into programming? Well, in programming, recursion is a way of doing a repetitive task by having a function call itself. A recursive function calls itself, usually with a modified parameter, until it reaches a specific condition. This condition is called the base case. In our earlier examples, the base case would be the smallest Russian doll, or the person at the front of the queue. Let's check out an example recursive function to understand what we're talking about. Here, we're defining a function called factorial. At the beginning of the function, we have a conditional block defining the base case, where n is smaller than 2. It simply returns the value 1. After the base case, we have a line where the factorial function is calling itself with n minus 1. This is called the recursive case. And this creates a loop. Each time the function is executed, it calls itself with a smaller number until it reaches the base case. Once it reaches the base case, it returns the value 1, and then the previously called function multiplies that by 2, and the previously called function multiplies it by 3, and so on. This loop will keep going until the first factorial function called returns the desired result. It's a bit complex, right? Let's add a few print statements to see exactly how this works. So here we can see the function kept calling itself until it reached the base case. After that, each function returned the value of the previous function multiplied by n until the original function returned. Cool, huh? Next up, we're going to check out some more examples of when to use recursion and when it's best to avoid it. By now, you've seen what a recursive function looks like, how to write a base case and a recursive case. You might be wondering, why do we need recursive functions if I can just use a for or while loop? Well, solutions to some specific problems are easier to write and understand when using recursive functions. A lot of math functions like the factorial or the sum of all the previous numbers are good examples of this. If a math function is already defined in recursive terms, it's straightforward to just write the code as a recursive function. But it's not just about math functions. Let's check out a couple of examples of how this could help an IT specialist trying to automate tasks. Let's say that you need to write a tool that goes through a bunch of directories in your computer and calculates how many files are contained in each. When listing the files inside a directory, you might find subdirectories inside them, and you'd want to count the files in those subdirectories as well. This is a great time to use recursion. The base case would be a directory with no subdirectories. For this case, the function would just return the amount of files. The recursive case would be calling the recursive function for each of the contained subdirectories. The return value of a given function call would be the sum of all the files in that directory plus all the files in the contained subdirectories. A directory of files that can contain other directories is an example of a recursive structure, because directories can contain subdirectories that contain subdirectories that contain subdirectories, and so on. When operating over a recursive structure, it's usually easier to use recursive functions than for or while loops. Another IT-focused example of a recursive structure is anything that deals with groups of users that can contain other groups. We see this situation a lot when using administrative tools like Active Directory or LDAP. Say your group management software allows you to create groups that have both users and other groups as their members, and you want to list all human users that are part of a given group. Here, you would use a recursive function to go through the groups. The base case would be a group that only includes users, listing all of them. The recursive case would mean going through all the groups contained, listing all the users in them, and then listing any users contained in the current group. It's important to call out that in some languages there's a maximum amount of recursive calls you can use. In Python, by default, you can call a recursive function 1,000 times until you reach the limit. That's fine for things like subdirectories or user groups that aren't thousands of levels deep, but it might not be enough for mathematical functions like the ones we saw in the last video. Let's go back to our factorial example from the last video and try to call it with n equals 1,000.
Factorial 1,000.
See that error? It's telling us that we've reached the maximum limit for recursive calls. So while you can use recursion in a bunch of different scenarios, we only recommend using it when you need to go through a recursive structure that won't reach 1,000 nested levels. All right, we've just added recursion to your growing scripting toolbox. They're ready for you whenever the situation calls for it.
Congratulations on finishing this lesson in the Google IT Automation with Python certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career certificates.